Welcome to the webinar. Today's webinar on precision balanced feeding of post-feeding saltpet lambs. So in sheep rearing, if we consider weaning, it is generally done from 2 to 3 months of age. And after that, generally male lambs, that is ram lambs, are reared for meat purpose mostly. Then female lambs are reared for the replacement use. So nowadays, if you see number of farmers, entrepreneurs are involved in ram lambs rearing intensively. That is from 3 to 4 months of age, 9 months of age. But if you see the lamb growth rate, mortality rate, profit from the intensive reared lambs, it varies to a large extent due to several factors. Out of that, feeding is one of the important one. So under stall feeding of the lambs, advantage is we can meet all the nutrient requirements precisely and also economically to achieve maximum growth and also profit. So in this context, so we are going to discuss about the balanced ration formulation process and feeding. Under the heading, first we will be discussing about the objective of feeding, then nutrients and calculation of nutrient requirements, then feedstuffs to meet the nutrient requirements, the guidelines for precise balanced ration formulation process, then feed preparation and feeding. First of all, what is the objective of feeding? So the objective of feeding is to provide all essential nutrients in adequate amounts and optimum proportions to meet requirements for the different physiological functions, from maintenance of the life process and health, reproduction, lactation, and growth. This is the objective of feeding, which is known as balanced feeding. So in this definition, you can see two words. That is, one is adequate amounts and optimum proportions. So adequate amounts means we have to meet the minimum requirements. Optimum proportion means we need to maintain proper ratio between certain nutrients, most of the nutrients. So then only the nutrient utilization will be proper. We can expect the expected performance and productivity. Okay, so in addition to that, while formulating the rations, we should see the economics. The ration, whatever we make, that should be economical and also safe. Here, what is precise means whatever the nutrients we meet, that should not be excess. We have to meet the minimum nutrient requirements, but that should not be excess. Okay, so to fully exploit the genetic potential of the lambs. Now coming to the nutrients, so there are different nutrients needed for the maintenance of the life process and health and also growth in case of lambs. The first one is energy, then fiber, protein and amino acids, minerals, vitamins, then water. Coming to carbohydrates, so in the rations of lambs, actually we have to provide structural carbohydrates as well as storage carbohydrates to meet the energy requirements. Simple sugar are also some extent meet the energy requirements. In addition to that, structural carbohydrates are also important to maintain the stable rumen environment because it provides bulk, and also for the optimal nutrient utilization and also to maintain the health. So as far as fats are concerned, it is a concentrated source of energy. So part of the energy can be met from the fats. Fats are also important source of essential fatty acid and also needed for the absorption of fat soluble vitamins. Lipids, it is very important structurally as a component of cell membranes, and also it is needed to perform regulatory functions related to hormones and eicosanoid actions. So in general, lipids and fat requirements in the diet can be met through roughages as well as concentrate and also through vegetable oils and animal fats. As far as proteins and amino acids are concerned, actually the body needs amino acids through proteins. So that is necessary for the cell and tissue growth and also to perform numerous other functions. So in ruminants, the protein requirement is met from two different sources. One is from the microbial protein synthesized in the rumen. Second one is from the dietary protein escaped in the rumen fermentation. So in case of minerals, we know there are two types of minerals. One is major elements, the second one is trace elements. So major elements, there are 7, and trace elements around 22 are there, but out of that, generally we consider 7 elements in the ration formulation process routine. Even though these mineral elements are needed in very minute quantities, their division in the diet, they can produce an adverse effect on the different physiological functions. So when we formulate rations, so we will be using different types of feedstuffs first to meet the energy and protein requirements. But whatever the feedstuff we use to meet energy and protein requirement, that will not meet all the mineral requirements of the lambs. So that means we need to use different mineral supplements to meet the mineral requirements of the labs. So among minerals as well as between minerals and other nutrients, there are a number of interactions. Suppose if one mineral is in excess, it can interfere with the absorption and utilization of the another specific mineral. For example, if excess potassium in the diet, so that can interfere with the absorption of magnesium in the rumen. Same way, if excess levels of molybdenum and sulfur can interfere with the absorption of copper. So in this mineral interaction, there are so many interactions have been described. For example, if you take calcium, so calcium can interfere with the absorption of zinc, that is excess calcium. So excess calcium can interfere with the absorption of manganese, copper, iodine, as well as iron. So like that for most of the minerals. So in some minerals it is one-way interaction, some minerals it is two-way interaction. For example, if you consider phosphorus and magnesium, excess of phosphorus can interfere with the absorption of magnesium. But the same way, excess of magnesium can interfere with the absorption of phosphorus. So that's why we need to follow the specific ratios between minerals. It is more important. So as far as vitamins are concerned, we know there are two kinds of vitamins. One is fat-soluble vitamins and the other one is water-soluble vitamins. That is including B-complex vitamins and vitamin C. So water-soluble vitamin, most of the water-soluble vitamins and vitamin K, so requirements can be met through rumen bacterial synthesis. And as far as vitamin D is concerned, if animal is exposed to sunlight for sufficient period, so vitamin D requirement can also be met for the labs. Similarly, if we provide sufficient green forages, okay, so that can meet the vitamin A and vitamin E requirement. So in addition to that, so animals should always to be provided with water, drinking water, because it is important for the survival of the animals. Then also to carry out various functions out of that. So two basic functions, that is related to body metabolism and body temperature regulation. So these two are important. We have to understand that as far as ruminants are unique in that they can utilize poor quality fibrous feedstuffs. Second thing is they can also utilize non-protein nitrogen like urea. So on fermentation of these poor quality fibrous feedstuffs, so volatile fatty acids are produced, then microbial cells are synthesized. And if you see the major energy supply and protein supply, volatile fatty acids supply major part of the energy and microbial protein supply major part of the protein. So this is the basic information. Now coming to the balanced ration formulation process and feeding. So first we have to calculate the nutrient requirements according to the feeding standard. Then we have to use available feedstuffs to meet the nutrient requirement. Then we can formulate the ration. So after that, we have to go for the preparation and feeding. So for the calculation of nutrient requirements, we have two kinds of feeding standards as far as labs are concerned. So one is from NRC USA, that is Nutritional Research Council USA. So that is nutrient requirements of small ruminants, published in the year 2007. Second one is nutrient requirements of sheep, goat, and rabbit, published by ICR in the year 2013. Okay, one thing we have to consider as far as feeding standards are concerned, when we calculate the nutrient requirements, we have to consider feeding standards only as guides. Why? Because whatever information we see in the feeding standards, those information are generated by conducting experiments using specific animals at specific agroclimatic condition using specific feedstuffs. So that means here we need to make adjustment for the agroclimatic condition, the type of feedstuff what we use. And another important thing is feeding standards. Generally, they differ in their recommendation. So we have to take the most relevant feeding standard, so which will be more relevant to our purpose. Okay, so in this case, energy and protein requirements can be considered from ICR 2013 standard. So mineral requirements also can be taken directly from ICR 2013 standard. But if you want to calculate more precisely for individual mineral requirements, so we can consider NRC 2007, but they have given a lot of criteria to arrive at the individual mineral requirement. So that means we need to consider all those criteria and we have to develop a program in Excel sheet. Then we can calculate the individual mineral requirements. So coming to vitamin requirements, vitamin A requirement for growth of the lamb is 100 retinol equivalent per kg body weight. So 1 retinol equivalent is equal to 3.3 international unit. Similarly, vitamin D requirement for maintenance, it is 5.6 international unit per kg body weight. And for growing lambs, so we have to provide extra, that is 54 international unit per day for every 50 gram average daily gain. And as far as vitamin E requirement is concerned, it is 10 international unit per kg body weight. So first part is over, that is calculation of nutrient requirements. Coming to the second part, that is about the feedstuffs. So here we have to use roughages and concentrates. And roughages we have green products and dry products. So we have numerous types of green products. Okay, non-leguminous, leguminous, and even tree leaves also we can consider in feeding. Similarly, in case of dry products, we have different types of crop residues like the leguminous, pulse crop residues, cereal crop residues, hulls and husk. So another type is hay, that is prepared from after drying the green products. Coming to concentrates, again we have different types: cereal grains, fats and oils, byproduct of cereals, byproduct of pulses, byproduct of oil seeds, and other agroindustrial byproducts, animal protein sources, non-protein nitrogen sources like urea, buffer agents, certifiers. So, and also mineral supplements and vitamin supplements, feed additives. So, depending upon the growth rate and also available feedstuffs. So, we need to consider and we have to select accordingly. And coming to the nutrient composition. So, to formulate rations to meet the requirements, so we should know the nutrient composition of the different feedstuffs. So, there are different sources. We have two online sources. One important source is PDPDF. So in that we can find information related to nutrient composition for most of the feedstuffs. So it is an international report. So they are continuously updating. So updated information we can get from this. One more online source is tropical forages. So in that we find information related to forage yield and cultivation practices, and also some extent nutritive value of the feedstuffs. Then a publication from NDDP. So that also, and a publication from ICR related to nutrient composition information is available, that also we can consider. In addition to that, individual research publication on chemical composition, nutritive value, and we can also go for the lab analysis of the feedstuff used in particular farm. If the farm is very big, organized farm, then now and then we can go for the lab analysis, particularly on proximate composition, cell wall constituents, macro and trace elements. But one thing what we have to remember is the nutritive value of feedstuff is not constant. So there are so many factors which influence the nutritive value. So that may be a feedstuff factors or animal factors. Okay, for example, if you may find some TDN value in the nutrient composition book. Suppose if the level of feeding is varying, so if animal is taking more feed, the digestible will be less, the TDN value will be less. So those factors we should consider, and accordingly we have to make adjustments. Okay, in the value while calculating the nutrient supply. So coming to the ration formulation process for the post-weaning lambs. So we have number of feedstuffs as I already we have seen. So we can make the different combinations like green fodder or silage and concentrate mixture. So green fodder, silage, leguminous forage and concentrate mixture, or complete feed containing both roughages and concentrate. That is, in that we can include crop residues and concentrate mixture. So like that, so there are so many combinations we can make, but whatever combinations we make, so we have to see the feasibility of the particular strategy for continuous adoption and also the animal productivity and profit margin. Let us see an example for the formulation of the balanced ration. Post-weaning lamb weighing 15 kg, growing at the rate of 15 gram per day under intensive system. So first we have to calculate the nutrient requirements. We can calculate as per ICR as well as NRC 2013 standard. So in this table you can see the nutrient requirements for almost all the nutrients. So only for dry matter, if we have considered dry matter intake as 4% of the body weight, since the body weight of the animal is 15 kg, so the requirement is 600 grams. So other information I have taken directly from the feeding standard. So it is directly available. Only DCAD. So as per the literature I have mentioned, so this may be the requirement. So regarding vitamin A, vitamin D, and vitamin E requirements, I have taken from the NRC feeding standard. Now coming to meeting the nutrient requirements. So first of all, we have to decide what kind of roughage and concentrate we have to use, and the ratio between roughage and concentrate. So in this case, we will consider maize silage as a roughage and concentrate mixture in the ratio of 50:50. Right. And consider the maize silage contain 8% CP and 60% TDM. So already we have decided that the dry matter intake is 4% of the body weight. So expected dry matter intake is 600 gram. So in this case, so 300 gram maize silage and 300 gram concentrate mixture, if we feed, so it will be 600 grams. So we can meet the requirement. Here we know the CP content of the maize silage and TDM content of the maize silage. So based on this, now we have to arrive at the how much percentage of crude protein we should keep in the concentrate and also TDM. If you look at the table, so first of all, we have to calculate, so how much CP the maize silage can supply, and also how much CDN the maize silage can supply. So on dry matter basis, it is 300 grams. So CP percentage is 8%. So CP requirement is 24 grams and TDN requirement is 180 grams. Okay, so this should be supplied through silage. Then remaining whatever is there, that should be supplied from the concentrate mixture. So remaining how much? 33 grams CP from the concentrate mixture and 193 gram TDN from the concentrate mixture. So considering that we need a concentrate mixture containing 24.3% CP and 64.3% TDN. But if you see the CP requirement, it is very, very high. Okay, so that means we need to use a very high proportion of costly protein supplements. Right, so this is not appropriate. Okay, so if you see the concentrate mixture composition, so it contains around 20% soybean, 10% DI cotton CK. So that means the cost will be very high. So considering this, if you supply 333 grams of concentrate mixture containing 90% dry matter and 1.2 kg of maize silage containing 20% dry matter or 0.85 kg of maize silage containing 33% dry matter. So we'll meet all the nutrient requirement, that is energy and protein requirement for the 15 kg lamb growing at the rate of 100 grams per day. Okay, so the composition of concentrate is not appropriate in certain aspects, and also the cost is, it is not cost effective. So when we decide the level of inclusion of different feed ingredients in the concentrate mixture are complete. So generally first we consider nutrient composition, then we consider nutrient availability, then cost of the feed ingredients. So as far as nutrient availability is concerned, it depends upon the nutrients interaction between nutrient interactions between nutrients, then presence of anti-nutritional factors and presence of pro-nutritional factors. Now, so one of the ingredients in the concentrate mixture is urea. So it is comparatively cheaper. If you look at the table, how it is cheaper, you can understand. See, we need to meet 290 grams of rumen degradable protein. For that, in 100 kg concentrate, if we prepare 7.2 kg of rumen cake, we have to include in the concentrate mixture. Same time, when we meet through urea, if we supply 1 kg urea, that means if you include 1 kg urea in the concentrate feed, so that will provide 290 grams of rumen degradable protein, right? But if we see the expenditure, in case of groundnut cake, it is 290 rupees. In case of urea, it is 6 rupees. Even though it is cheaper, there are certain constraints as far as use of urea in the concentrate mixture is concerned. The major problem is urea is rapidly hydrolyzed in the rumen and absorbed across the rumen wall. That means after absorption, it goes to the liver where it is converted into urea again. Okay, if the ammonia absorption is too much excess, then the excess ammonia can stay in the system, so it can lead to ammonia toxicity. So that's why, so in general, 1% urea in the concentrated mixture is recommended. So here in the picture, you can see how the urea is utilized, how the rumen degradable protein is utilized. So rumen degradable protein, finally it is also converted to ammonia. Urea is also converted to ammonia. For rumen microbial growth, so particularly for bacteria, most of the bacteria use ammonia as a nitrogen source. So for that bacteria, whether the ammonia has come from urea or rumen degradable protein, it is not important. Okay, so that's why we can include urea, but we should limit the urea inclusion. In addition to that, we should also see other factors which increases the efficiency of utilization. So what are the factors that influence the efficiency of utilization? Mainly there are two factors. One is presence of fermentable carbohydrates in the concentrate mixture. Second one is presence of type of protein and also the amount of protein. As far as readily fermentable carbohydrates are concerned, so why it is important means, so on fermentation, so it yields VAPs, which generally decreases the rumen pH. So if your rumen pH is less, some extent the ammonia absorption will be less. So because of that, the rapid absorption of ammonia can be prevented. Okay, so in this way, ammonia toxicity or inefficient utilization of ammonia can be, that is urea, can be some extent prevented. So what is the optimum ratio of the readily fermentable carbohydrate in urea? It is recommended as 10:1. So out of the readily fermentable carbohydrates, 2/3 should come from the starch. Why? Because starch is somewhat slowly fermented as compared to sugars. So in practice, Suppose if you are using cereal grains and molasses, so 15% ground cereal grains like maize and 5% molasses can be considered when we include 1% urea. So as far as protein is concerned, so urea will work better when in the low protein diets. If the protein content is less than 12 like that. Why? Because rumen microbial protein synthesis will be more efficient from the recycled urea and the protein content is low. And another thing is when we include protein supplements in the diet, when we include urea, we should see that we include only the protein supplements containing low level of rapidly degradable protein. For example, if you consider groundnut cake, it contains more amount of rapidly degradable protein. That we should not consider. Instead of that, we can go for the cottonseed cake or coconut cake. So if you evaluate this concentrate mixture, whatever we have prepared, so it contains sufficient levels of fermentable carbohydrate. That means maize is the sufficient level. But the CP content is very high. That means we need to change the feed means protein supplements. And also we have to reduce the CP content. So coming to mineral supply. So in general, what we recommend is include 2% mineral mixture in the concentrate mixture. So that is not actually correct in all the times. So in this case, we included a commercial mineral mixture containing some different minerals. But after inclusion, if you see the nutrient that is mineral supply, it's excess. You can see in this table. So it is meeting the dry matter, CP, and energy requirement. But as far as mineral requirement and supply is concerned, it is in excess. Okay, except as far as vitamin is concerned, only vitamin E is deficient. So if you see without inclusion of mineral mixture, only zinc, iodine, and selenium. So these three are deficient. So if we can able to make trace mineral mixture containing these three, so definitely we can meet the requirement more precisely. We can reduce the cost. We can improve the productivity. So that's why always we need not consider 2% mineral mixture in the concentrate mixture. In addition to that, the acid-base valence of the diet, that is known as the dietary cation anion difference. So that is also considered. The optimum level generally ranges from 200 to 300 milliequivalent per kg as per the literature, even though the research conducted in this field is very less. So in the prepared ration contains 251 milliequivalent per kg. So it is also appropriate. But when the DCAD content is low, we can add sodium bicarbonate to increase the DCAD content. And when urolithiasis is a problem in male lambs, we can consider ammonium chloride maximum 0.5% of the ration. So in the particular ration, vitamin E is deficient, so we have to invariably go for the vitamin E supplement. Now coming to the precisely making the concentrate mixture. So first, according to the deficiency, we can make mineral premix, then vitamin premix. So in this case, you can see only calcium, zinc, iodine, and selenium we have included. And in vitamins, all the three we have included. So the cost of mineral mixture will be very less as compared to commercially available mineral mixture. And in this concentrate mixture, so the mineral mixture is included at 1% level, and vitamin A, D is included 25 grams per 100 kg. So in this way, when we do, so we can meet all the requirements, all the minerals and vitamins also more precisely. Now coming to the issue of high content of CP in the concentrate. Okay, so how to overcome that? So to overcome that, invariably we need to include leguminous forages, replacing the non-leguminous forages, in this case silage. Okay, when we do like that, so definitely the protein requirement in the concentrate mixture will come down. Then we need not include high cost protein supplements in that. So here we have replaced maize silage with alfalfa equally. So it is meeting all the requirements. And if you see the concentrate mixture composition, here we have not included soybean meal. Only we have included cottonseed cake, which is necessary when we include urea. And it contains 19% CP and 70% TDM. So here also we need not consider inclusion of 2% mineral mixture. So the first example is feeding the concentrate and apaches separately. In addition to that, we can also make balanced ration containing both rapages and concentrate together, that is known as complete feed or TMR. Consider an example. We are including a sorghum stover as a crop residue, then concentrate. Sorghum stover is included at 50% level, then remaining concentrate. So what we can see here is that we have to include more amount of maize and more amount of soybean meal. Okay, because the sorghum stover is less in protein and also less in available energy. So to overcome, so this again high content of the concentrate, high content of the protein in the concentrate, we have to include leguminous forages or leguminous crop residues or tree leaves. And again, here also, we need not go for the supply of 1% standard mineral mixture, we can go for the tailor-made precision mineral mixture. But here we need to include vitamin E because it is always deficient. So we need to realize the importance of the leguminous crop residues. In one experiment conducted in ICRISA on the groundnut rams, when groundnut rams was fed as a sole feed, okay, 137 gram ADG was observed. And if we calculate the protein intake and energy intake, almost it is meeting the requirement. So such kind of high quality crop residues, that is leguminous crop residues, can be considered, and we can use them as a base roughage. Then we can go for the precision formulation. So in this table, what you see is we formulated here a high concentrate precision TMR. We fed between 3 to 4 months of age to the Takani loves. And what we observed was ADG of 172 grams per day, FCR 4.24. Feed cost was only 75 rupees per kg gain. Previously, by another student, the work was conducted on same origin Takani lands between 3 to 4 months of age. The feeding practice considered was 300 grams of concentrated mixture and green powder retrieved. So at that time, only 65 gram ADG was recorded. So you can see, you can observe the composition of the TMR as well as concentrate mixture. So in the TMR, 30% roughage is there and 70% concentrate. If you consider the roughage circumstover, so this is actually a PMR circumstover. So this SPV2018 is prior to release. Now it is released as a CSP particularly by IIM Hyderabad. So it is highly digestible. Okay, so that 50% we included. Then soybean oils as a source of non-forage fiber, that also 15% we included. Remaining 70% other concentrate. So we could be able to achieve 172 grams of ADG between 3 to 4 months, right? But when we included conventional concentrate and green powder, the ADG was very less. On the same lands, between 2 to 4 months and 4 to 6 months, we used a different TMR. Then we conducted experiments. That is, we observed the performance. So when we used high concentrate DMR, the result was different. When we used high roughage DMR. So in high roughage DMR, actually conventional circumstover was included at 50% level. And the high concentrate DMR, previously whatever we used, same thing we have used. Here you can see the difference. Between 2 to 4 months of age, the ADG absorbed was 144 gram and the FCR 4.16. Feed cost 86 rupees per kg gain. But at 4 to 6 months of age, so when we change the composition of the TMR, when we included high level of conventional circumstover, so ADG declined almost to 50%, then FCR also deteriorated. Feed cost per kg gain also increased tremendously. So what may be the problem? So the main problem here is the energy availability. The available energy might have been less, okay, because of inclusion of the circumstover. So in such cases, we can go for the inclusion of the high amount of cereal grains, or we can consider oils, which are concentrated source of energy, or we can go for the inclusion of the calcium source of fatty acids, which are always known as protected fat. In addition to formulation, so while preparation also we need to take precautions. Okay, so while procuring the feed ingredients, so first of all we have to physically verify for the color, odor, moisture, and also presence of stones, insects, fungus infestation, all those things. If you have any doubt, then we can reject. So we have to procure only quality feed ingredients. In addition to that, we can also go for the microbiological examination of the feed ingredients. So in this picture, what you see is a foldscope. So this is a paper microscope developed at Stanford University, and it is having magnification power of 140x. So we evaluated the usefulness of this one DBT project. So we implemented a DBT project. So what we found was the foldscope can be used to detect adulteration of the rice husk as well as sawdust, brands and other feed ingredients, and also to find out adulteration in oilseed meals, and also to differentiate calcium powder and dicalcium phosphate of rock and animal origin. It can be also used to detect iron contamination in cereal grains, and also it can be used to detect heat damage in the soybean. In the field, we used foldscope based methodology because on the spot we can use foldscope. So in two places, we could be able to detect a cheating of the supply of the dicalcium phosphate. So instead of calcite powder, instead of dicalcium phosphate, in the bag we found calcite powder. So if you consider the cost of the calcite powder is only 2 rupees 50 paise. Now the current cost of DCP is 60 rupees. And we also found we could be able to detect adulteration of rice husk in DORB, rice bran, wheat bran, and soybean using Fosco. And also we could be able to detect adulteration of urea in oilseed cakes like cottonseed cake and groundnut cake. And also whenever you procure mineral mixtures, if the mineral mixture is low cost, we should take precautions. Because low cost mineral mixtures generally they use low cost ingredients. For example, instead of using dicalcium phosphate, they will use rock phosphate, which contain large amount of chlorine, which is a cumulative poison. We should also store the feed ingredients as well as the fish to be properly in dry hygienic place. We have to use old materials first, then new materials last, and we should avoid stacking of the feed in direct contact with the floor. And as far as possible, we should utilize all the materials within 3 months. And mixing of concentrate or complete feed is also very, very important. So uniform distribution of all the feed ingredients in the finished feed is very, very important. Otherwise, we may not deliver the specific concentration containing feed. Coming to the feeding, so as far as growing lambs are concerned, we have to go for invariably equilibrium feeding, whether it is complete feed or when we use roughages and concentrates separately. So initially we can go for roughages equilibrium, then we can adjust the concentrate. When we feed roughages and concentrates separately, and the feed offer should be continuously increased as the age advances. If necessary, we can change the composition, nutrient composition of the feed also. So in addition to the whatever factors we discussed so far on the post-weaning labs as far as feeding is concerned, in addition to that, other factors can also influence the post-weaning lamb growth, like nutritional factors, feeding at the ewes during last 6 weeks of pregnancy, feeding at the ewes during first 3 weeks of lactation, so because that depends upon the milk yield, and feeding at the lambs until weaning, that is milk feeding as well as solid feeding. Coming to non-nutritional factors, genetic potential for growth and feed conversion efficiency, healthcare, housing, and other managemental risks can also influence. So these factors we need to control, then we have to go for such kind of feeding practice. So overall, when we adopt a precision balanced feeding in case of post-feeding starved labs, so definitely we can see improved efficiency and efficiency of nutrients, so enhanced growth rate and reduced mortality rate, better FCR, and also reduced feed expenditure and higher profit. But one thing what I need to say here is, so after formulation, actually we need to go for the trial and error, because there are uncertainties as far as nutrient requirement calculation is concerned, and also the nutrient value of feedstuffs. So we need to go for some kind of trial and error. We have to formulate, we have to feed, and we have to change according to the response. So like this, if you do, so definitely we can feed the lambs more precisely to economically to achieve maximum growth rate and profit. Thank you.